Recording stopped on the last video because I didn't have enough storage on my phone, so I had to delete the videos that I'd already uploaded anyway. So we were already halfway through explaining declination and GHA. But to summarize, declination you can think of as being analogous to latitude and GHA as being analogous to longitude, but with regard to celestial bodies. Remember, a celestial body is only projected down onto the Earth in what is called its geographic position. So if this is a star, the star is not here. The star is somewhere way up in space, but it can be dropped straight down and land here, and we can think of it as being located here if we were imagining it having a location on Earth. Because of that distinction, we do need to remember that what we're working with isn't on Earth, so we use different terms from latitude and longitude. But obviously, something equivalent would be very useful so we could define its position on Earth. So what we use is declination and GHA. Now, declination is the simpler of the two because it's pretty much exactly the same as latitude. You can just measure the distance from the equator up to or down to the geographic position of the body. Just like latitude, it's just going straight up or straight down. The one major difference, and this is just a difference in notation so that you can distinguish the two in writing, is where you place the north-south notation or symbol. So you can see if we were to say that the geographic position here was up in 30 degrees, 10 minutes north, that would be a true latitude. So that would be as if it were an island. If it was physically on Earth, you would write this to describe its latitude. But this is a geographic position. This is just representative of the star's location. So what you would write is north 30 degrees, 10 minutes. And that is a declination. All you do is you move the n from the end to the beginning, just to say this is clearly distinct from latitude. No one would ever write a latitude with an n at the beginning. That would only ever come at the end for latitude. So for declination, it's always there, so you can very clearly distinguish the two, and you know what you're looking at. Likewise, if this was an island at 15 degrees, 20 minutes south, this would be perfectly correct for latitude. But if we're talking about a celestial body, it would be south 15 degrees, 20 minutes. That part's not too hard. You're just treating it the same way. All you need to remember is to put the n somewhere else and then to call it declination, don't call it latitude. And then once you've done that, you're nice and set. GHA is a little bit different. Now, longitude, I'm going to move this just so it's easier to see. Longitude, like latitude, is just measured straight out. Instead of from the equator, it's now measured from the prime meridian, and it's just the distance away from the prime meridian. There. So let's say this one had a longitude of, 45 degrees, 0 minutes west, and this one had a longitude of 30 degrees, 30 minutes east. That's totally fine. Now, GHA stands for Greenwich hour angle. So it's the hour angle, which I'm going to go into detail in the next videos, the different types of hour angles. But it is the angle of a celestial body moving along the ecliptic or just in the direction that they move, which they always move to the west. How far along that track they are from Greenwich. The big difference there is that means that it's only ever going west. So while longitude goes up to 180, hour angles go up to 360. They don't stop at the anti-meridian, they continue around. So longitude was measured like this. Greenwich hour angle also measures this as this one going that way. So the GHA of this geographic position would also be 45 degrees, 0 minutes. But there's no W because it's not west of the prime meridian. All GHAs are to the west. What that means for this one is that we, instead of coming out here like we did for longitude, we go all the way around and keep going around and then stop there. That is the GHA of any body that's in the east. It's more than 180 degrees all the way around the Earth. I don't care that you're closer to the prime meridian going this way. We only ever measure things going in a westerly direction because that's the direction the sun moves, that's the direction the stars move, that's where everything moves. So in this case, its longitude would not be 30 degrees, 30 minutes east. Its longitude would be 300, or its GHA would be 329 degrees, 30 minutes. Flat. No east, no west, because we're still going in the same direction. This just means we are 45 degrees away from the prime meridian in the direction that the stars move. And this is 329 degrees, 30 minutes away from the prime meridian in the same direction. So there's no sign given to GHA in any condition. You don't care about what hemisphere it is. Declination, you do care. You do care if it's north or south of the equator. But GHA is just measured as a single continuous loop in a circle.